Okay, so your attention please, everyone.
Good morning, everybody. We are here to present our project on wireless battery charging using RF radiations. Today, as we all know that mobile devices have become a very major part in our life. The main problem with them is charger. You have to connect to the charger and get it charged. So, life has become so much messy with these cords and chargers. So technology is trying to get out of this charger and try something wireless one. That's what my project is about, wireless battery charger. Just imagine you are talking on your cell phone, you are playing a game on your cell phone and simultaneously your phone is getting charged. That too wirelessly. That itself is very time saving and convenient. Although there are power mets, but for that thing you have to put your cell phone on the power met and wait for its battery to get charged. There is some kind of connection. You can't do anything simultaneously. So the other option of wireless battery charger is a better one. The basic idea in our project is we are transmitting RF energy from the transmitter side and through free space, and at the receiver side we will harvest that energy to charge the battery wirelessly. Now going deep into it, in the transmitter section, next slide. In the transmitter section we are using a commercial FM transmitter that transmits the power of about 0 to 10 watts at a frequency of FM band 92 megahertz, and monopole antenna is connected to it, which transmits the power through free space in the form of RF energy, and that power reaches the receiver side. Now at the receiver side also we are having the same monopole antenna, receiver antenna, that works at the same frequency and it receives the power and it forwards that power to the rectifier circuit. Now here we are dealing with very high AC input power, high frequency AC input power. So normal diodes cannot rectify the power. So we have used the Schottky diode and in the rectifier circuit that rectify the high AC input power into DC output power. So the output of the rectifier circuit, the DC output power, is used to charge the battery wirelessly. Next slide. This is the graph of our results. When the monopole and the monopole transmitter and the receiver antenna both were coupled with each other, the voltage and current measured at the rectifier output were like 10.1 and 2.5 milliamperes, and the power at the receiver side was about 2.424 milliwatts. And as we increase the distance between the transmitter and the receiver, the power get on reducing as it is inversely proportional to the distance square. This is the table of our graph, that when we increase the distance between both the transmitter and the receiver antennas, the power kept on reducing. So, next slide. Okay. The problems, initially when we started this project 4 months ago, we were dealing with cordless phone as a transmitter device. But it gave very low power of about 0.500 milliwatts. So this was not suitable to charge our battery. So we also deployed Flashstone as a signal generator. The Flashstone, it worked on the frequency 22 gigahertz. So it was also not suitable as the diodes were not the diodes suitable for it were not available. So we switched over our plan to order a commercial FM transmitter as a transmitter device. Also, previously we were dealing with the cellular band frequency, but for this frequency, the quad bridge Schottky diodes were required to rectify the power, which were commercially not available. So we switched over our plan by using cellular band. Also, we plan to design a waveguide as a transmission media when we were dealing with the cellular band frequency. But as we switched our plan to FM band, that was not used. Now to put the actual implementation of this project, to get a better output, better power, our research shows that using high gain parabolic antennas that transmit a more power, it is more suitable because they transmit more power, and at the receiver side more power will be received and a battery will be charged easily with less time. Also, multiple rectifier circuits can be used at the receiver side. When we use, using multiple spiral antennas at the receiver side, they are more sensitive. they have more sensitivity. They can extract very small signals also. So by using these antennas at the receiver side, we can extract more power, and by rectifying by using multiple rectifier circuits, we can harvest more energy from the power. Actually, 4 months ago, this idea was very difficult for us. I mean, we were planning to switch on to change our project, but by constant efforts and by our guide support, special thanks to Mr. Mohammad Khan, Carl Oliver, and Mohsen Mullah to guide us. And today we are here to present it before you, and we came up with the idea. Thank you so much.
Probably a few questions about this one.
I have a question. Did you think about the cost? How much would it cost?
Yeah.
To implement?
The FM transmitter, commercial transmitter, it costed $200. We ordered it.
And how about the licensing issues?
Yeah, actually we were experimenting it, and so we have not figured out about the licensing thing. Because if we have to license the whole thing, then we would have most likely.
For a commercial implementation?
Yes, commercial implementation we will not be using 92 megahertz in the FM band. The actual implementation can be very much different. That we can use we will use a satellite to actually transmit the energy, or we may go on to our cellular base station that can transmit the energy. That can be in the cellular band. That can be maybe if a company tries to implement this project, commercially, they can license the band, frequency band if they want.
Actually, we wanted to come out with the idea first, and after that we can think of it.
I get that.
Thank you.
Thank you so much.
Yes.
Are there any commercially available devices which can be used for charging?
Yes, they are commercially available devices, but they are not actually harvesting the RF energy. They are using induction as a source of harvesting the energy, and they are like power banks available, for charging the laptops, and naturally some of the power banks for charging the mobile devices.
One question is that if you are transferring the power with RF, is there a possibility someone could cap your power than your target user?
Yes.
Sure.
Definitely. Actually, we are targeting not for a specific group of people so that they can use it. We are targeting this for everyone.
It is common.
It is usable for everyone. Everyone having mobile devices, mobile phones, laptops, laptop. So everyone needs energy. Just imagine you are talking on phone and your phone is getting simultaneously charged. Why you need corded charger? Why you need a mobile phone to connect to the power source?
I think we have there's a question here. Yeah, go ahead.
Can you just pick up the RF off the air, or do you have to design a transmitter and use it that way?
Yes, we can pick up the RF of the air, but it is better if we design particularly for this purpose.
But it is not suitable to charge the battery. If we won't get that much energy from the air.
Yeah, teamwork, audio and yeah, go ahead.
Okay, the question is simple. If you calculate the cost of your, let's say you are going commercial, do you calculate the cost of this equipment compared to other green sort of
I have a very crazy idea. Yes. I have a very crazy idea about it. Like I want, if I get a chance, I want to set up a satellite above in the space. It can trap solar energy, and that satellite will transmit RF energy to a specified area, and from there we can, actually harvest RF energy. It has been implemented during World War II. Crazy idea, it will go to like millions of dollars.
For our own construction, it costs us just approximately $200. But if we are doing it commercially, the amount will kind of reduce.
So one last question at the back here. I like your experimental design there, and and so I think it's a good start at figuring out whether or not it works. But after you got looking at your data, is it worth it?
Yes, it charges the single AAA battery. Or even if you can charge your mobile battery also.
But you guys were at very close range,
Yeah.
right? You're, I think,
We
10
have-
centimeters or something like
Yes,
that.
10 centimeters.
But as soon as you go like across the room or something like that, well,
But
It won't. It
yeah,
won't.
it will.
It won't work. We need
Yeah.
high
Because the
power
antenna-
transmitters. We need
Yeah.
high sensitivity receiver antennas.
So at the end of the day, is it worthwhile to think about a commercial implementation of it, or is it just a good experiment?
So as point of the business perspective, it is a good worthwhile because you are saving lots of energy and money of the companies. You know, you are saving chargers, you are saving time of the people. They are getting devices charged. So if it is implementable, if it is it is researched well in future, and it is thought of well, it is worth. I think it is.
Additionally, I feel that with a lot of work, with a little more work, we can increase the distance. It's just that this is a starting point. If we put in a little more work, then we can increase the distance.
This was just the implementation of our idea. The high gain, using those antennas, high gain antennas, we can commercially use that with this idea.
Okay, yeah, I think that'll be all. Thank you.